We're going to continue working through these review problems for the Math 137 test number 3. We're ready now for number 11. And actually, this isn't my favorite problem. Let me sort of give you the philosophy of this problem and then see what they were trying to do. One of the ways to approach a problem like this, you see it's two parts A and B. Oftentimes what they will do is, what I think is probably a better kind of problem, if they ask you this question, if they said, go find the exact value of cosine of 5 pi over 12, your response would be, well, this is not one of those special angles, so I don't know what the exact value is, and I cannot answer that. And that would be correct. But every once in a while, there's a workaround or an alternate way to get this answer. And in this case, you realize that if you take pi over 6 and add pi over 4, these are both special angles. I know the trig functions for these two angles. Now, if you happen to add these together, we have to get a common denominator, which would be 12. So pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. And now you add them together, and lo and behold, you get 5 pi over 12. So what you realize is, if we're asked to solve this problem, cosine of 5 pi over 12, we can actually rewrite this problem. Instead, say the cosine of 5 pi over 12, I can call it the cosine of pi over 6 plus pi over 4, because these two, we add them together, equal 5 pi over 12. And then what you can do, this is now, we have a formula for this. This is section, what is it, 5.3. This is what we call one of the sum formulas, where the cosine, when you add two angles together. So you look at your formula sheet, and the cosine of adding two angles together is this right here, cosine, cosine minus sine, sine. So now you can say this is cosine pi over 6 times cosine pi over 4 minus sine pi over 6 times sine pi over 4. And now we can actually find the exact value of this 5 pi over 12 angle. Let's just go and finish this part of the problem. These are all special angles, so I've actually memorized these. If you need to, you can look at your unit circle. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. The sine of pi over 4 is square root of 2 over 2. Now to simplify this, if you multiply two square roots, you can just multiply the numbers under the square root. So square root of 6 over 2 times 2, 4, minus square root of 2 over 4. Since these have the same denominator, we can make this one fraction. And that is the exact answer for the cosine of 5 pi over 12. Now the whole point of this problem is, if you look at part A, they have cosine pi over 6 plus cosine pi over 4. What we ended up calculating was cosine of pi over 6 plus pi over 4. You notice here you're adding the angles, then taking the cosine. This one, you take the cosine of each angle separately, then you add them. I guess the reason why they do this, they want to show you that these actually are not the same. In other words, you cannot take the cosine of an angle plus the cosine of a second angle and rewrite it like this. These are not the same. So let's go ahead now, let's do part A, and we'll see that part A is going to be different than this. So this is actually the answer for part B. We sort of did part B first. Let's do part A. Once again, fairly straightforward, because we know these are special angles. Cosine pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. We can combine these into one fraction. So this is the answer to part A. This is the answer to part B. I sort of did these backwards because I know what they're trying to prove in this problem, but to me, sort of a strange way to do things. What I think is really important is that every once in a while you're given an angle and you're asked to find the exact value. And when you first look at it, the angle is not a special angle. I don't know the cosine of 5 pi over 12. But every once in a while, if you can take that initial angle and somehow break it up to where you either add or subtract two of our special angles, then you actually have a way to find this trig function. So I'm going to go now look at the answer for this problem 11, just to confirm my answers. Now that I've sort of explained what we're doing. So I'm going to share the screen, and I'm going to actually, I'm trying to figure out I'm trying to find hang on just a second. I'm trying to figure out well, let me share this and see if I can figure it out. Oh, right here, I think it is. Sorry. There it is. Wow. So here's problem 11. Here's a problem we just did. Let's go, and I'll turn on the key. And actually, I found this thing. I can hopefully just click on the problem here, and it'll jump right to it. So part A, square root of 3 plus square root of 2 over 2. That looks correct. And part B, yes, our two answers are correct. All right, let's go on to problem 12 now. So now we're dealing with problems that are using these sum and difference formulas. So problem 12, let me write it down, and then I'll go to the full screen. So problem 12, once again, it's the same form, same concept. Part A, they say tangent of 45 degrees plus tangent of 150. They don't know what that is. And then they say for part B, what's the tangent of 195? And they sort of give you a hint that 195 is 45 plus 150. All right, so let's go work out this problem. So once again, the way I like to think about it is, if I was to try and find the tangent 195, that is not a special angle. I'm sort of stuck. I can't find an exact value. However, 195 is 45 plus 150. These are both special angles. I know the tangent of these angles. So in a sense, well, let's go into this one first. So tangent of 45 is square root of 2 over 2 over square root of 2 over 2, right? Sine over cosine. That's going to be 1. Tangent of 150 is really the same thing as like 5 pi over 6. 5 pi over 6, the sine is going to be 1/2. The cosine is negative square root of 3 over 2. This becomes 1 minus 1 over square root of 3. I'm sure they will not like this answer, so let's go ahead and let's rationalize this. Multiply top and the bottom by square root of 3 over square root of 3. So 1 minus square root of 3 over 3. If I change this 1 to 3 over 3, my guess is this is the kind of answer they probably want for part A. I don't make any mistakes. So for part B, in a sense, what we do is we realize tangent 195, I can say, is the tangent of 45 degrees plus 150 degrees. And now I go use my formula for the tangent of adding two angles together. So it's going to be, you add the tangents on the top, so it's going to be tangent 45 degrees plus tangent of 150 degrees all over 1 minus, and you multiply the two. So now these are all special angles. Tangent of 45 is just 1. Tangent of 50, we already figured out up here what tangent of 150 is. Square root of 3 over 3. So plus square root of, I'm just checking to make sure I didn't make any mistakes up here. Let me check this again. So tangent 150 is the sine of 150, which is 1/2 over the cosine negative square root of 3 over 2. Yeah, that should be correct. And then over 1 minus tangent of 45, which is 1 times tangent of 150. Although this is actually a negative. So I did sort of mess up. So we get 1 minus square root of 3 over 3 over 1 plus square root of 3 over 3. So if I try and simplify this, I'm going to combine these. This is going to be 3 minus square root of 3 over 3. And this is going to be 3 plus square root of 3 over 3. These three cancel. Now the question is, what does WebAssign want? Is WebAssign okay with this? Or do they want to get rid of that square root? Let's just go look at the answer. And if this is not quite right, then maybe we can try and adapt it to what their answer is. So let's go back to the go turn on the answer key. Takes a minute to kick in. Go back to problem 12. Okay, yep. So I'm going to write down their answers and write down our answers. And I want to show you that they're basically, I think, the same. So sometimes, I don't know, when you do the homework on the test, I would give you credit if just the form looks different. So here's the WebAssign answers. 1 minus 1 over square root of 3 and 2 minus square root of 3. And here are our answers. 3 minus square root of 3 over 3 and 3 minus square root of 3 over. Or actually, I hope when you do the homework and even on the test, WebAssign is somewhat flexible. Because to be honest, I would have thought like this one, our answer, this is what they would have given, but instead they break it up and they even have a square root in the denominator. Why they chose this form, I don't know. This to me, I would have thought math people like it better. But I think if I break this up into two fractions, actually what I could do is, if I look back, actually, when we did that problem, we got to this point right here, 1 minus 1 over square root of 3. Little did I know I could have stopped right there, because that's the answer they have. I thought they would have want to put it in a different form. So that proves that our answer is correct. Now for this one, I have to do a little bit of work, see if I can make it look like this. And this, they choose to get rid of this denominator by multiplying, what's called multiplying by the conjugate. The same two terms, you just change the sign in the middle. Of course, you have to multiply the top and the bottom by the same thing. When you multiply two conjugates, you can always do a little shortcut. The shortcut is you take the first term and you square it, and it's always subtract, and then you take the second term and you square it. Of course, when I say first and second terms, doesn't matter which parenthesis I'm using, the first terms are the same, the second terms are the same. So when you square the second term, so it's always the first term squared, and it's always a subtract, and then the second term squared. When you square a square root, it's just this. Now in the numerator, I have to multiply these out. So I'm going to FOIL these, and I'm going to try and just do it. If I didn't make any mistakes. So this top is going to be 12 minus 6 square root of 3 over 6. And now you notice this term and this term and this one all have a common factor of 6. It means I can divide all three of these by 6. And when I do that, I get 2 minus square root of 3. So I confirmed we do in fact have the same answer. Yeah, so WebAssign, hopefully, if you put this answer on the test, you'll get it correct. But for sure, I'll give you credit for it if for some reason WebAssign doesn't like it. Let me actually get a new marker. That one's sort of running dry. And now we're ready for problem 13. So let's see what problem 13 is all about. Turn off the answer key so we don't cheat ourselves. "13. Express as a trigonometric function of one angle." All right, so let's write this problem down and we can talk about what they're doing. So cosine of 17 degrees times the cosine 48 degrees minus the sine of 17 degrees minus the sine, or times the sine 48 degrees. All right. So here's the idea here. They're almost like using the sum and difference formulas backwards. What do I mean by that? Let's do this. When we look at our difference formulas, this sheet, the angles are all U and V. I'm going to go ahead, I'm going to just assume, for now, I'm going to call the 17-degree angle U and the 48-degree angle V. So I'm going to replace these up here, and you'll see in a minute why I do that. So really I have cosine U times cosine V minus sine U times sine V. What I'm going to do is I'm going to go back to my formula sheet, and I hope one of my sum or difference formulas takes this form, where it's cosine, cosine, minus sine, sine. And I look here, and I notice this first one, cosine times cosine, minus sine times sine. That's the formula for the cosine of adding two angles together. So this, what I've written here, is really the formula for this. What does that mean? That means for this problem, U is 17 and V is 48 degrees. So this whole thing, I can simply say, I simply add U and V together. 17 plus 48 is 65 degrees. So see what I've done? I'm in a sense using the formula backwards. I called 17 degrees, I'm going to call it U. I decided to call 48 degrees V, so I replaced the 17 to 48 with U and V. And then I went to the formula sheet and I said, is this one of my formulas? Yes, it is. This is the formula you use when you add two angles together and take the cosine. Well, for my problem, I called U 17 and V 48. So this whole thing, I can rewrite as simply the cosine. I could have written it here. The cosine of 17 degrees plus 48 degrees. So it's almost like I used the formula backwards. So cosine, and that's what they asked for. They asked for, I forget how they worded it. Let's see if the answer is cosine of 65 degrees. And it is. So they said express as a trigonometric function of one angle. As a matter of fact, the next one, I think they're going to do it again. Same kind of problem. So hopefully it should go fairly quickly. Number 14, express as a trigonometric function of one angle, sine of 56 times cosine of 9 plus, all right, so let me write down what this one is. Sine of 56 degrees times cosine of 9 degrees plus cosine of 56 degrees times the sine of 9 degrees. Just to make it easier to see, and you don't necessarily have to do this, I'm just doing it, whoops, let me go. So here's the problem. Now, you don't have to do what I'm going to do here, but I do it just to make it very clear and obvious. Once again, I think what's going to happen is this is one of those sum or difference formulas sort of backwards. So for me, I just do this because it makes it very easy to see and make sure I don't make any mistakes. I sort of take this angle 56, I'm going to call it U. I'm going to call 9 degrees V. I'm going to rewrite this, maybe I'll even do it here, as instead of 56 and 9, I'm going to put U and V in there. So when I go to my formula sheet, it's very easy to see what's going on. So sine of 56 is sine of U, cosine of 9 is cosine of V, plus cosine of 56. That's cosine U, sine of 9 degrees is sine of V. So I'm going to go to my formula sheet. First thing I notice is they're added together. So that narrows it down to these two in the middle here. And now you notice this one's cosine, cosine, sine, sine. I don't have that. I have sine, cosine. So sine of U, cosine of V, sine of U, cosine of V, plus cosine U, sine V, cosine U, sine V. So it's this formula right here, this third one down, which this is the sine of U plus V. So this is the sine of U plus V. And for me, my U is 56, my V is 9. So when you're all done, this whole thing can be rewritten as the sine of 65 degrees. So let's just confirm that. This is number 14. Sine of 65 degrees. All right. Let's see what's next. Number 15. Turn off the key. Let's go to 15. All right, use the given conditions to find the exact value of the expression. So it looks like we got an angle alpha, and they say the sine of alpha is negative 5 over 13. And they tell us the tangent of alpha is greater than 0. And then here's what they're really asking for. They're asking for what is the sine of alpha minus pi over 3. So let me write down all this information. And then we can try and solve this problem. So they say the sine of alpha equals negative 5 over 13. And the tangent of alpha is greater than 0. And then basically the problem is they want to know what's the sine of alpha minus pi over 3. All right. So let's take a look at this. So here's the basic problem. Here's information we're given. So really what this, in essence, this is a problem where we're taking the sine of the difference of two angles. Alpha is an angle and pi over 3 is an angle. So in this case, they have alpha. We don't really know the angle, but the second angle is just given to us. Let's go ahead. Let's go to our formula sheet. Let's just write down the formula for the sine of the difference, which is this one. So the difference of two angles, the sine is the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. So I'm going to look at this formula sheet, and I'll go ahead and write it down. So it's the sine of the first times the cosine of the second, and then minus the cosine of the first times the sine of the second angle. So by using my formula, I get this. Now, you know what? Cosine of pi over 3, sine of pi over 3, I know those. Those are special angles. In a minute, we'll just plug those numbers in. However, our real job now is to figure out what is the sine of alpha and what's the cosine of alpha, so I can plug those in. And that's where we have to go back and use this information they've given us. First thing I want you to make aware of, let's figure out which quadrant our angle's in. You always have to know their quadrant your angle's in. So when you have a negative sign, you know that is going to be the third or fourth quadrant. That's where the sign's negative. But then at the same time, they say the tangent's positive. Which quadrants have a positive tangent? 1 and 3. So what do they have in common? Quadrant 3. So this angle is in quadrant 3. Now what I need for my equation, I need sine of alpha, cosine of alpha. I'm given sine of alpha. So the last thing I need is I need to figure out the cosine of alpha. What I'm going to do is, to find cosine of alpha, I'm going to do what I always like to do. I'm going to create a right triangle for alpha. It's going to be based upon this. Sine of alpha is -5 over 13. I don't really care about the negative sign for now. I'll take care of the plus or the minus later on. All I care about is the numbers. Sine is opposite over hypotenuse, right? So katoa, opposite over hypotenuse. Therefore, this other leg, Pythagorean formula says it's 13 squared minus 5 squared. That's 169 minus 25, square root of 144, which is 12. This other leg is 12. So now, if I look at this angle alpha, I really want to know what the cosine of alpha is. Cosine is so ca, adjacent, over hypotenuse. Now, alpha is in quadrant 3. What's the cosine in quadrant 3? It's negative. So now I've got everything I need for this formula. The pi over 3 is already here. I know sine of alpha is -5/13. I now know cosine of alpha is -12/13. So I can plug everything in. Sine of alpha is -5 over 13. Let's go ahead and plug in. What's the cosine of pi over 3? That's in the first quadrant. It's that sort of like that third point up there. I believe it should be 1/2. Minus cosine of alpha is -12 over 13 times the sine of pi over 3. Once again, first quadrant, it's square root of 3 over 2. So this is -5 over 26. These two negatives cancel. Plus 12 square root of 3 over 26. Now I assume Webber-Stein will combine these, and typically you put the positive one first. So here would be my guess of the answer, as long as I didn't make any mistakes. But you never know what Webber-Stein is going to do. So just going to look at the answer and see if I'm in the ballpark, or maybe I could have made a mistake. So I'm going to go turn on the key. This is number 15. That's good. 1 over 26 times 12 squared root of 3 minus 5. So yep, actually that's pretty much the form. I mean, I made it all one fraction and they put the 1 over 26 out front, but it's basically the same. All right, that's good. All right, let's keep going. See what we have next. Number 16. I don't want to see the answer. I want to see if we can figure it out. All right. Looks like actually the same kind of problem. So number 16, let me write down the information. Use the given conditions to find the exact value of the expression. So they say cosine of alpha is 24 over 25. The sine of alpha is less than 0. And really what they're wanting to figure out, the cosine of alpha plus pi over 6. All right, so there we go. Really the same things we just did. So let's do the same thing. Let's go ahead and find the formula for the cosine of adding triangles together. And let's write it out. So it's this very first formula, cosine, you add triangles together. So it's cosine, cosine minus sine, sine. So it's cosine of alpha times cosine pi over 6 minus sine alpha times sine pi over 6. Once again, I already know cosine of pi over 6, sine pi over 6. What I have to figure out is cosine of alpha, sine of alpha. Well, they've given me cosine of alpha. All I need is to know what the sine of alpha is. And we're going to do the same thing like the last time. I'm going to take this information about alpha, create a right triangle, and that'll give me a way to figure out sine of alpha. So let's first look at this angle alpha. Cosine is positive. What does that mean? That means it has to be quadrants 1 or 4. That's where the cosine is positive. The sine is less than 0. It means a negative sign. Negative sign means the angle has to be in the 3rd or 4th quadrant. And I compare these. 4th quadrant shows up in both. So it looks like alpha is in the 4th quadrant. So let's take this cosine information and let's create a right triangle. Cosine is so ca adjacent over hypotenuse. And if I'm going to get this other side here, it's going to be 25 squared minus 24 squared, square root of all that. That's one where you're probably going to need a calculator. So 25 squared, I think it's probably 625. I went a bit more, yep. But minus, I'm not sure what 24 squared is, 576. But when you subtract them, which is sort of nice, square root of 49, which is 7. So this leg is actually 7. The only thing I really need is sine of alpha. So based upon this triangle, sine of alpha is opposite over hypotenuse. Now I'm in quadrant 4. The sine is always negative in quadrant 4. So now, so we have to plug everything in. Cosine of alpha is 24 over 25. Cosine of pi over 6 is square root of 3 over 2. Sine of alpha is negative 7 over 25. And then sine of pi over 6 is 1/2. So this is 24 square root of 3 over 50. Subtracting a negative, so it's plus 7 over 50. If I combine them, looks like that's my answer. Now we'll see what WebAssign says. Let's go back and turn on the key. 16. But over 50, 7 plus 24, square root of 3. Wow. All right, that's good. Normally I make math errors, but so far I'm trying to be careful. All right, 17, let's go up to 20. Then I'll take a break again. I think there are maybe 28 or 29 total problems. So let's go to 17. If alpha and beta are acute angles such that cosine of alpha is 15/17 and tangent of beta is 4/3, find the following. Three-part problem. Sine of alpha plus beta, cosine of alpha plus beta, and the quadrant containing alpha plus beta. All right, let's write this stuff down. Then we'll see if we can figure out how to solve it. So first of all, alpha and beta are acute. Acute angle means it's less than 90. So right away we know both these angles are in quadrant 1. It's going to make it sort of nice. Then they say cosine of alpha is 15/17. And they say tangent of beta is 4/3. Part A, I want to know what's the sine of alpha plus beta. All right, well, this is adding two angles together and taking the sine. That's one of our formulas. It's going to be this third one here. Sine u times cosine v plus cosine u plus sine v. Let me just keep this handy. Let me just go ahead and write that out for this. So according to the formula, it's going to be the sine of alpha times the cosine of beta. And then it's plus, and then cosine of alpha times the sine of beta. So if you take a minute, if you call u alpha and v beta, this is what you should get. Now I have to see if I can figure out what these numbers are. I need sine of alpha, cosine of alpha, sine beta, cosine beta. I have cosine of alpha. I have tangent of beta. Actually, what I'm going to do is I'm going to separately take the information we've been given and create a right triangle. First for alpha. I was told for alpha, the cosine is 15/17. Cosine is ca, so ca adjacent over hyper. Oh, wow. I'm so sorry. I forgot to turn this on. So let me go back. I haven't done a whole lot. I wrote down the information, and then they want to know sine of alpha plus beta. So I simply went to the formula sheet and used the formula. And now I'm going to go in and create a right triangle for alpha based upon cosine of alpha is 15/17. And then in a minute, I'm going to create a right triangle based upon tangent of beta is 4/3. So sorry, maybe you were yawning at your computer as I was talking and you weren't really seeing anything. So here's the alpha, and these are both acute triangles, so they're both in quadrant 1. So this other leg is going to be 17 squared minus 15 squared once again. 17 squared is 289. 15 squared. $225. So 289 minus 225, 64. Which is 8. So that side is 8. Let's go ahead and create a right triangle for beta. Tangent of beta is 4/3. Tangent is TOA, right? Opposite over adjacent. Opposites 4, adjacents 3. Now, if I use Pythagoras on this, that was pretty easy. Hypotenuse is 5. So these are both in quadrant 1. So actually, I should be able to just go in. Sine of alpha, here's my alpha triangle. Sine is opposite over hypotenuse. Cosine of beta, here's my beta triangle. Cosine is so ca, adjacent over hypotenuse. Plus, I'm back to cosine of alpha. So I'll go back to my alpha triangle. Cosine is so ca, 15 over 17. Times sine of beta, here's my beta triangle. The sine is so opposite over hypotenuse. So 24 over 17 times 5 is 50. I think it's 85. Plus 4 times 15 is 60 over 85. So we can combine those into 84 over 85. So what do you think? If you're making any mistakes here? 17. Or actually 17a. 84 over 85. Now we have to do cosine of alpha plus beta. So it's going to be similar, just a different formula, right? So if once again look at your formula sheet, cosine, adding two angles, it's cosine, cosine minus sine, sine. So cosine alpha times cosine beta minus sine of alpha sine beta. Now I pretty much know all this stuff. I know cosine of alpha. Here's my alpha triangle. Cosine's 15 over 17. Cosine of beta, here's my beta triangle. Cosine, so ca, 3 over 5. Minus sine of alpha, opposite over hypotenuse. Times the sine of beta, opposite over hypotenuse, 4/5. So 45 over 85 minus 32 over 85. 13 over 85. Did anybody see that answer before we closed it out? So 13 over 85. Looks like that's correct. Now the final answer is what quadrant is it in? Well, let's just look. Here's the sign, it's a positive number. Whoops. For this alpha plus beta, when you add the angles together, the sign is positive, which means the sum of the angles, the new angle, has to be in quadrants 1 or 2. And the cosine is also positive. Cosine's positive in 1 and 4. So what do they have in common? I think the sum of this angle has to be in quadrant 1. And that's correct, quadrant 1. All right, let's do 18 because 19 we start a new section. So maybe we'll take a break after 18. So let's write it down and we'll take a look at it. Use an addition or subtraction formula to find the solutions of the equation that are in the interval 0 to pi. Enter your answers as a comma-separated list. If there is no solution, enter no solution. All right. So it's going to give us an equation. Cosine of 6t times cosine of 3t equals negative sine of 6t times the sine of 3t. And they basically want to know they want to know what t is, and t can be from 0 up to pi. I guess I should write the number down. What was it, 18? Yep, 18. This is one where we've done this before. We're going to use the formula backwards. So the first thing I have to do is figure out which formula it is. So once again, here's what I'm going to do. Just like with those angle problems, I'll just set u equal to 6t and v equal to 3t. So I can rewrite this as cosine u times cosine of v equals negative sine of u times sine of v. But let's get them all on the same side. So let's add sine u, sine v to both sides. So really what we have is cosine u times cosine v plus sine u times sine v. So flick our formulas, it's cosine, cosine plus sine, sine. Which one is that? Cosine, cosine plus sine, sine. Cosine, cosine plus sine, sine. Looks like the cosine of u minus v. Well, u and v are 3t and 6t. So I can just say the cosine of 6t plus 3t cosine of 9t. Of course, this all equals 0. This whole thing equals 0. And now I need to try and solve it. Well, to solve this, I'm going to have to use my old U substitution. Let U equal 9t. So this becomes 0 equals cosine of U. So now if I think of U as an angle, what's the angle where the cosine is 0? Well, I could think of two possibilities. Pi over 2 plus 2 pi n, and now both these may not meet the conditions, but I'm just off the top of my head. I'm not going to assume what is or is not within my interval until I actually see I made a mistake here. You probably all saw that. So I'm now solved for U, but I know U equals 9t. So if I'm going to solve for t, I divide both sides by 9, and you get pi over 18 plus 2 pi n over 9. That's from the first one. And the second one, divide both sides by 9, 3 pi over 18 plus 2 pi n over 9. Of course, this was just down to pi over 6. So now, I want to see the solutions between 0 and pi. When n is 0, you get pi over 18, and you get pi over 6. How about when n is 1? When n is 1, you get pi over 18 plus 2 pi over 9. That's same as 4 pi over 18. That looks like 5 pi over 18. You put 1 here. It's like pi over 6 plus 2 pi over 9. Wow. How about this is 3 pi over 18, 2 pi, 5 pi over 18. Looks like I repeat. Did I do that correctly? Pi over 18 plus, when I put in 1, yep, pi over 18 plus 4 pi over 18. When I put in 1 here, it's 4. Let's write this out. Pi over 16 is 3 pi over 18. And this is 4 pi over 18. Looks like it's 7 pi over 18. Now what happens when n is 2? Well, this first one you get pi over 18 plus 4 pi over 9. Wow, this is quite messy. This is going to take me forever. So this is 8 pi over 18. So 9 pi over 18. Looks like that's pi over 2. And then this one, when you add n, I hope I'm doing this right. I'm going to check because I hope I'm not doing all this work and then I'm doing something wrong and going down a rabbit hole. Since I can look at the answers, no reason to. what is this, 18? Oh, didn't turn on the key. Yep, I messed up. All right, this happens. So here's a good example. Let's see if I can find my mistake. Maybe you already saw it as I was working it, but I don't want to make these videos again because of the time. So make sure I copy the problem down correctly. So I changed to U's and V's. So cosine, cosine plus sine, sine. You know what? Right at the beginning, I was supposed to subtract. Yowza. One little mistake. Yowza. So this was all for naught. So let's go back where I got off track. Amazingly enough, 0 equals cosine 3t. Now I am going to once again do the U substitution. So 0 equals cosine of U. So where's the cosine? 0, pi over 2 plus 2 pi n, and 3 pi over 2 plus 2 pi n. Of course, when I get back to the t's, this first one, divide everything by 3. Pi over 6 plus 2 pi over 3n. And the second solution gives you pi over 2 plus 2 pi over 3n. And then you start, sorry. So what I did, let me go back. Here was my mistake. When I went up here, I figured out it was cosine of U minus V, and I added the U and the V instead of subtracting. So I ended up with 9t, and it should have been 3t. So I picked up at this point and went back and said, here's really what I need to solve. 0 equals cosine of 3t. Then I did do a U substitution. 0 equals cosine of U. Two solutions. U equals pi over 2 plus 2 pi n, and U equals 3 pi over 2 plus 2 pi n. But I need to switch it back to t, so I said U equals 3t, so this whole thing, U equals this equals 3t, U equals this equals 3t, and I'm going to take these two and solve them for t, which means I divide both sides by 3. So the first equation is this, and here's the second equation. So now I start plugging in numbers for n's. When n is 0, the first one is pi over 6. The second one's pi over 2. When n is 1, I have pi over 6 plus 2 pi over 3, which is 4 pi over 6. Looks like it's 5 pi over 6. When n is 1 down here, pi over 2 plus 2 pi over 3. If I get a common denominator, 3 pi over 6 plus 4 pi, that's 7 pi over 6. But then you notice my limit is from 0 to pi. 7 pi over 6 is bigger than pi, so I have to stop there. And I should end up with 3 solutions: pi over 6, pi over 2, and 5 pi over 6. Let's see if that's correct. So pi over 6, pi over 2, 5 over 6. Yep. So my apologies. Although, to be honest, that was okay because even teachers can make mistakes for not being careful. That's why, especially on the test, we'll be very careful. All right, so let's stop now. Then I'm going to pick up with number 19, which is the next section of the book.